are about to begin with session number 2 for the day, and the topic for session number 2 is transitioning towards green steel and sustainability.
As you can see that I am going to make a presentation today about green steel and sustainability, and the title of my presentation, Outokumpu is the global leader in sustainable stainless steel. And the biggest point is that we have 70% lower carbon footprint as compared to the global average. In last year, in 2022, our net sales was 9.5 billion euros, which we achieved by selling 2.1 million ton of stainless steel. And another important thing to note here is that 94% was the recycled content in our stainless steel, which is industry highest number, and we are very proud of it. Now we have also introduced Circle Green, which is an industry innovation, and this material is 100% stainless steel, but down to 8% of the carbon footprint of industrial average carbon steel. So you will be thinking that what is the importance of carbon footprint and why it is becoming a more and more important topic for us. I will cover that point in next slides. Before that, I will just show you on the global map. Outokumpu, we have manufacturing plant in our headquarters is in Helsinki, in Finland, and then we have one major plant which is in Tornio, in Finland. We also have 3 manufacturing plants which are in Sweden, 3 plants are in Germany. We have a very large plant in Calvert in USA, and also a plant in Mexico. Apart from these plants, we also have many service centers which are located across the globe, and we are trying to service just in demand requirement of our customers globally. One of the important point of Outokumpu is that it is the probably only company stainless steel in the world with our own chrome mines. And as you know, for stainless steel, chrome is the major raw material, and we have our own mines, which gives us lot of benefits, and also from sustainability point of view, which I will cover in next slides. We have taken very ambitious climate targets, and probably we are the only stainless steel in the company in the world, and probably also the steel company in the world who has taken science-based target. We have taken a target that by which 1.5% degree centigrade emission is to be achieved. As you can see, the emission intensity of Outokumpu in 2016, our average emission was 2.2 tons of carbon dioxide for production of 1 ton of stainless steel. And our ambition is that we will reduce it by 42% by 2030. If we see the figure of the last year, that we have reached to 1.7 ton already, and we are on very good track to reach the target set for 2030. One important thing here for you to notice that when we are talking about carbon emission, we are talking about scope 1, scope 2 and scope 3. Many a times people are only considering either scope 1 or scope 1 and 2 and not considering scope 3. Scope 3 is also very important, and in my opinion it is more important than scope 1 and 2. So for those who are not familiar what is scope 1 and scope 2 and scope 3, scope 1 is coming from our own operation. So that means whatever production process that we are following, from that process how much is the carbon dioxide emission. Scope 2 is coming from the electricity that we are buying from elsewhere, and that becomes scope 2. Scope 3, it's depending on the raw material that we are buying from other suppliers. So the overall, when we have to consider carbon emission, we need to consider all the 3 scopes, otherwise you are not giving a complete picture for your carbon dioxide emissions. So let's spend some time about understanding the carbon footprint of stainless steel. most of you are familiar with the stainless steel production methodology. So normally stainless steel, especially in European mills, they are produced in an electric arc furnace. And electric arc furnace, for producing of stainless steel, there are two major raw materials. One is chromium and second is nickel. And if we take a specific, very common grade 304, which all of you are aware, normally the chemical composition of 304 is having 18% of chromium and 8% of nickel. So in our process, as we mentioned before, that we are using recycled material or scrap, whatever you like to call it. So on the left hand side you can see that we are buying scrap from other suppliers, and when we are receiving the scrap, there is a possibility that chemical composition is not exactly matching with the product that you are going to supply. So for example, the variation in the composition of scrap, for chromium it can be 16% plus minus 1%, and for nickel it can be 8% plus minus 0.5%. So in this process of manufacturing, what we are doing in the electric arc furnace, we are heating it and melting it, and after that we are checking what is the chemical composition of the melt. And let's take two examples. In one case you have chromium 16.5%, nickel 8%, and in second case chromium is 15.5% and nickel 7.5%. So you may think that for the first heat, nickel is as per the requirement, so there is no need for us to add nickel. But unfortunately, when you will increase chromium, so that means you are diluting it. In that case, nickel percentage will also change, and for that also you need to add some more nickel, and that's how the final chemistry tuning is done in AOD. So what you will do in AOD primary addition, you will add nickel metal and chromium. Also in the second case also similar thing will happen. You will add more chromium and you will add more nickel. So this primary raw material, chromium and nickel, they are the main emission driver, as you can see on the right hand side. So for typical Outokumpu stainless steel carbon footprint of 2022, you can see that how much is the carbon dioxide emission for scope 1, scope 2 and scope 3. So as I was mentioning, scope 1 is basically that whatever carbon dioxide emission during our manufacturing process. And one of the main difference between us and others, because we have our own chrome mines, so for us any carbon dioxide emission happening in the chromium, that will come under scope 1, but for many other producers who are buying chromium from others, for them it will be the scope 3. So that is the reason that we need to see overall picture of scope 1, 2 and 3, then only you know how much is the total carbon dioxide emission. So in case of scope 1, our carbon emission is about 1 million ton per year. And if you see scope 2, our carbon emission is about 368,000, and this figure is quite low as compared to many other suppliers. It is mainly because the energy that we are using in our European plants, they are basically carbon neutral energy. Almost 86% of energy that we are using in our manufacturing process, it is carbon neutral, but still there is some energy which is generating carbon dioxide, and for that we have to consider them in scope 2. If you see the size of the scope 3, and you can see that almost 2.7 million ton of carbon dioxide is coming from scope 3, and which is the biggest source of carbon dioxide emission. And if you deep dive in scope 3, you will see that 38% is coming from nickel itself. So in Outokumpu, in Tornio plant for example, if we are using 1 million ton of production and 94% is coming from scrap, so just for only 6% addition of raw material, 2.7 million ton of carbon dioxide is emitted, which is a huge number, and this is the main focus for all stainless steel producers to see that how they can reduce their scope 3 emission. The second other element which is very important is lime, and lime is basically used in stainless steel production for slag formation. And unfortunately, there are no good carbon neutral lime supplier around the world. So that means even if we want to reach, our target is to reach zero, but we can never reach zero unless all the raw material that we are using, they are producing also carbon neutral material. We are taking a lot of steps to reduce scope 1, scope 2 and scope 3. So in case of scope 2, for example, that Outokumpu is investing that wherever we are using carbon based coke, we can use bio coke, or we can use, we have tied up with a company called Fortam. They are making nuclear small module reactors, so they can give us carbon neutral. And we have recently also announced our interest in one mine in Canada for supplying nickel, so that our supplier, we can also work with them so that they can start to supply carbon reduced nickel, which is one of the major focus area for us. If we compare Outokumpu carbon dioxide emission, carbon footprint as compared to our peers, so the stainless steel, which is primarily produced in China and Indonesia through blast furnace process, as per our estimates, the emission is 7.4 ton for each ton production of stainless steel. If we take the industry average, it is 6.1. If we take European peers, other players in European market, where most of them are producing it through electric arc furnace, our best estimate is that their carbon footprint is about 2.8, including scope 1, 2 and 3. And for Outokumpu, last year our number was 1.7 with all the 3 scopes. So to summarize our discussion so far about carbon footprint, scope 3 is very crucial, and we have to focus on procurement of our raw material and how do we ensure that we can reduce our carbon footprint while sourcing our raw material. Second thing is that recycling content is important, but even you want 100% recycling of stainless steel, which is not possible because there is not so much of scrap available around the world that everybody can start producing stainless steel by scrap. So main focus is that if we think more about increasing recycling content, that is one strategy, but main is that we need to focus on primary raw materials. And third thing is that about transparency, and it is very critical that many companies, they are, when in the annual report or in the data that they are publishing, they are not providing all the information related to scope 1, 2 and 3. And it is not that we need to compete with each other, but it is the target for ourselves that how we can do better as compared to last year and continuously improve and reduce our carbon footprint. Moving to the second part of my presentation, which is Circle Green. It is a new product which we have launched, and the idea is towards zero carbon stainless steel. So we are not committing that it is a zero carbon steel, but it is towards zero carbon stainless steel. So this famous slide of Outokumpu, 100 years and nothing has changed, except everything has. So what is the meaning of it? That stainless steel is not a new material, and the grades which are produced like 304, 316, they are in the practice for 100 years and people are using it. We have now launched green steel, 304 grade for example, with same chemical composition, with same mechanical properties, but with different carbon footprint. And how do we achieve this green circle material? That you can see that this material is having 92% lower than the global average. So you have seen before in my slide that Outokumpu is already at 70%, but now we are offering this product to our customer which is having 92% less carbon footprint as compared to global average. So global average is 6.1 as I have mentioned before, and this green circle will offer product which will be only 0.5 ton of carbon dioxide per ton of steel. So how are we going to achieve it and how we are reducing it? I think this kind of question will be coming to your mind, that what are the different processes that you are following and how it is happening that we are able to reduce. So this we are guaranteeing that minimum 50% emission reduction as compared to conventional Outokumpu product, including scope 1, scope 2 and scope 3. And the results which are given, they will be certified by third party, so that you will be given a certificate which will ensure that how much of carbon dioxide emission that was done for producing this material. And also we are not using any offsetting of emission. It is not that for this product we are doing something, but we are passing on the emission of carbon dioxide of this material to some other product which customer is buying, like a normal stainless steel. So that we are not using any of those things. So that is the reason I was saying transparency is also very important. So this is a reference case for 304 grade which I have been continuously talking about. So how we are achieving it? We are doing it by using special raw material. So that means if customer is placing order for certain green stainless steel, in that case the raw material selection will be done in such a way that we are using those raw material which are having least carbon footprint. And second strategy is that we will use low carbon energy for production of this material. And third is that production efficiencies are at different level for circle green material. So one question may ask that if production efficiency is possible, in that case why don't you do for all the product that you are making, why you are giving it only for circle green material? So take the example that we do melting and then we cast slabs from continuous caster. So in ideal situation, all the hot slab should go to hot rolling so that there is no temperature reduction, and then again you have to reheat it for hot rolling. But from practical point of view, it is not possible that each and every slab you can send to hot rolling mill from production constraint point of view. So many a times you have to cool it down, you have to keep it in the storage and then take it to hot rolling whenever you require it. But for circle green, we follow a special process and everything is aligned in such a way so that there is no reheating of the material. So how, by doing these three methods, how we have reduced scope 1, scope 2 and scope 3. So for scope 1, we are able to reduce it by 96%. So now you can see that as compared to earlier, the scope 1 emission is reduced 96%, scope 2 is reduced 89%, but for scope 3 still with our best effort, we are able to reduce it only by 56%. So scope 3, as I was saying, it is most challenging one for all the stainless steel producer and lot of focus is required. So now you can see the new block in this graph, and our normal Outokumpu conventional offering is 1.7 and down to 0.5 now. So you can see that there is a lot of improvement and our target is to reduce it further. But as of now, we are giving guarantee to our customer that this material will be at least 50% lower than our regular production. So this is the guarantee to our customer. We have started offering this material now for some time, and there are many customers who are buying this material. So far we have offered 6 grades. In case of Moda family, we are giving 1.4003 and 1.4016. For core family, which is 304, 304L and also 1.4509. For Supra family, for 316L or 1.4404. So these are the 6 grades which are being offered currently in the market. Along with the material, this kind of certificate that you are seeing on the right hand side is issued to the customer, and here you can read that for producing this material, 0.481 ton of carbon dioxide was emitted, and the batch number and metal certificate number is given, and it is also given that in case of a regular 304L, our standard emission is 1.688, so that we are able to reduce it by 72%. So we are able to achieve more than 50% also, but at least 50% is guaranteed for our customers. So I can share that some of the customers who have tried Autocompo green circle material and some of the big names in the industry. For example, Fiskars, they were one of our first customer who started to use circle green material. They are a very premium cookware company, and they like, because they are also committed to the sustainability and offering product to our customers. So we have good partnership with them. Second example is related to automotive application. So ThyssenKrupp materials processing, they are our partner for supplying automotive material in Europe. So two of the companies, Gsse and Buran, they are basically automotive components manufacturers. So for exhaust system, they are using circle green material. Not only the end user, but also a lot of distributors, they have also shown interest, and we are giving, for example, material to Swedrup, and also one company in Denmark, one company in Nordics. So we have now good set of customers, and we are continuously developing with more and more customers who are interested to use this material. So after covering this topic, now I think it is very important for us that why carbon dioxide footprint is so important for the industry. Because everybody is talking about sustainability, green steel, but why? What is the importance of it? So just to illustrate one example, again for 304 grade. So if a customer is buying 4,000 tons of stainless steel in a year, and if he is buying 2,000 tons from China or Indonesia and 2,000 tons from Autocompo standard stainless steel, in that case you can see that carbon dioxide emission will be 18,200 tons in a year. So for buying 4,000 tons of stainless steel, you are emitting 18,200 tons of carbon dioxide in the environment. What customer can do? They can switch to Autocompo average material. They can buy one entire material from Autocompo, and that way they can reach to 6,800. So in place of 18,200, they can reach to 6,800. Much better with our new circle green material. If they shift 4,000 tons of procurement to circle green material, the carbon dioxide emission will be maximum 3,400. So there is a saving of 14,800 tons of carbon dioxide by one customer by switching the source of supply. And why 14,800? If you want to visualize what is 14,800 tons of carbon dioxide, which is a very important point. We grow one plant today. It will take 40 years for it to decompose 1 ton of carbon dioxide. So if somebody who is emitting 14,800 tons of carbon dioxide, they need to plant 15,000 plants, 15,000 trees, and they will get returned in 40 years. So that means if company is running continuously, every year they need to plant 14,000 trees so that they can become carbon neutral. So the much easier way is that to use your raw material intelligently and use product which are more carbon neutral. Another important aspect is that product carbon footprint from cradle to gate. We are providing it on our material test certificate. So when we are giving test certificate to our customer, it is mentioned that for producing this material, how much of carbon dioxide was emitted, which is a very important point for our customer, because they also calculate how much is their total emission, and they can check it very easily from our test certificate report. So we are very proud that this calculation model, it has been verified by WSP Global, which is a Canadian company, and because of our good work in this area, last year in the sustainability category, we have got Microsoft Intelligent Manufacturing Award 2023. Because this kind of methodology, in our opinion, is going to be used by all the stainless steel producers either today or tomorrow, but customers are going to ask for this kind of information whenever they are going to buy stainless steel, and not only stainless steel, for any raw material in the future. So it is better that all the colleagues also from the industry, from stainless steel, they should also start looking into this area. So this was my last slide. I think for question answer we will wait, and we will take all the questions together. So if you have any questions, please write it down so that we don't forget, and then we can take it in the end. Thank you so much.
Thank you. Thank you, Rajiv. It has been a very interesting presentation, and we will take the question answers later. So the next speaker today is Mr. Kalyan Bhattacharya.
Yeah, thank you for this opportunity and the great theme conceived by the organizers under this expo, Gsse Expo. Certainly we are here, the stainless steel producers in the stainless steel ecosystem. We should also talk about how we are placed towards the sustainability and protecting our environment. So the theme for today is transitioning towards green steel and sustainability. So before we talk about the green steel, I would like to present some slides about our own company, Jindal Stainless Limited. So Jindal Stainless Limited, founded in the year 1970 by Shri O.P. Jindal, late Shri O.P. Jindal. This is India's largest stainless steel producing company and the top 5 globally. Presently we have a crude steel capacity of about 3.4 million tons and we are scaling up to 3.4 million tons. In another location, we have 0.8 million tons, and that thereby we have about 4.2 million tons totally. We have a manufacturing center in Gsse, Haryana, and Jajpur, Odisha. There are some figures, some indications about our company. Serving about 120 SKUs, number 1 stainless steel producer in India, top 5 decades of group excellence, exporting to more than 40 countries. More than 3 MTPA crude steel capacity at present, 350 billion net revenues, and last year EBITDA about 3.6 billion. How are we aligned to the UN SDGs? What we did was we have mapped all our processes, all our activities, all our principles, commitments and goals to the UN SDGs and clubbed it under 5 pillars. So 5 pillars being the care for environment, empowering stakeholders, well-being of employee, product stewardship, and ethical conduct. Under each pillar, we have taken focus programs that will align to the UN SDGs. There are 17 UN SDGs which have been defined, out of which JSL has picked the ones relevant to its industries and have taken concerted efforts in meeting the commitments towards the SDGs. So you can see the listed ones here are all most relevant ones in the industry, right from the air emissions, waste management, biodiversity, conservation, water conservation, materials management, renewable energy. Going over to the stakeholders, you see empowerment, suppliers, assessment, local community, CSR. Well-being of employees, one of the major focus areas in which we treat our employees direct, indirect, and also the community. We have a very robust community outreach in which our CSR program also reaches out to the local community and across our manufacturing units. The direct employment, indirect employment, all are taken care through CSR programs. We have a product stewardship in which we have a robust R&D. We have been developing several grades in different applications, right from defense to marine to several other applications. We have been pioneered several grades through our R&D. We are bringing in operational efficiency and excellence, several programs in brand reputation management. Then ethical conduct, we have started about 11 to 13 policies all approved by the board that are taking care of our ESG framework. A snapshot of our past year's performance regarding climate change, emission intensity, circular economy, renewable energy, water management and biodiversity. My co-panelist, Mr. Sherry, just presented, and he was right that we are not presenting here the entire gamut of scope 1, 2 and 3. At present, in India, almost all the manufacturers, they are presenting in the code scope 1 and 2, and some companies are presenting only scope 1. So here the numbers which are presented before you are the emission intensities of scope 1 and 2 per ton of 1.98 tons of CO2 per ton of crude steel. Scope 3 mapping is a very complex process in which we need to consider the raw material, the goods, produced goods and service, your input goods and services, the logistics, and several other things which are part of the scope 3, the mapping of which is very complex, and there are many considerations which are to be made before we embark on a scope 3 emission calculation. The renewable energy, we have utilized renewable energy to the tune of 33 gigawatt hour. 58% of recycling ensure the circular economy, contribution to the biodiversity by 10,000 plus plantations, and a zero liquid discharge program across all our manufacturing units. Community development CSR spent for 12.15 crores, 0.35 as LTIFR and the safety management systems, training and awareness, learning and development. These are our core strength areas we are building, that going forward we need to have a competence. Beyond competence, we need to have a skilled workforce and a talent pool available with us going forward. So we are investing in the learning and development, training and awareness, and moving towards zero harm policy. These are the few of the policies I was mentioning. These are the part of our corporate governance, product stewardship, and stakeholder engagement. We have covered almost all the policies that are relevant to our manufacturing industries under the current regulatory environment in India as well as globally. So we have all the policies in place which are globally relevant. We have embarked on a Gsse decarbonization journey. We have announced net zero by 2050 and achieving 50% emission reduction by year 2035. So the major initiatives which have been planned to achieve this in the short term of 2035 are we are adding 300 megawatts of renewable energy across both our plants. This 300 megawatts will be round the clock, which requires about 900 megawatt of installation base of wind and solar. So this is a very ambitious project we have embarked on. Despite we ourselves operating two thermal power plants, 250 megawatt thermal power plant, but going beyond, our expansion will be powered through renewable energy. So this is a very ambitious target we have taken. We have already signed up MOU for 100 megawatt and we are proceeding for another 100 megawatt, and it will be followed by the last tranche of 100 megawatt. So in total 300 megawatt for both of our manufacturing facilities. We have started a green hydrogen project, a pilot project in Hisar, 90 cubic meter per hour, and we are adding another capacity of 700 to 800 nm³ per hour green hydrogen in our charge. It's remarkable to mention here that this is the first green hydrogen plant in steel industry at Gsse, that's a 90 cubic meter per hour. It's being followed by the 700 to 800 nm³ per hour plant at Jajpur. This green hydrogen, it will be primarily used to replace our present use of cracked ammonia. And after this, we will be finding more and more applications for green hydrogen, moving towards a green hydrogen steel making processes. We have regarding the 300 megawatt in the first place, that is through PPA. The third one I am mentioning, this within on-premises solar installations of 21 megawatt at Jajpur and 6 megawatt at Hisar. We have planned for biomass co-firing. We have planned for several extensive heat recovery, innovative energy efficiency projects, switching from rail to road to rail transportation, then carbon capture and utilization, and e-mobility. These are some glimpses of our solar renewable energy use on premises. We have a 7.3 megawatt floating solar plant. We have used the water space within our premises, the water reservoir, and we have utilized that space to install one of the very few floating solar plant within the factory. We have a presently installed capacity of 6.5 megawatt as a rooftop solar and adding 28 megawatts more. As you see, this is a picture of our chairman, Sri Ratan Jindal, along with the chairman of Renew Power. We have signed the first 100 megawatt renewable power RERTC, and discussions are on for the other tranches which I already explained. This is the green hydrogen I was talking about. So 90 megawatt we have already started the plant at Hisar, and another 700 megawatt Jajpur. This entirely it will be used for replacing cracked ammonia, and later we also are exploring the use of green hydrogen for process heating and injection in upcoming blast furnace. Circular economy is a very important thing to achieve your green standards and to have a sustainable manufacturing processes. Circular economy, we have to ensure that not only the scrap recycling, but also that all our products and byproducts and wastes, they are recycled, reused, repurposed or reduced. Waste reduction, waste elimination, reduce, reuse, recycle and repurpose should be our motto going forward. So several hazardous processes we have mapped, and the waste from those hazardous processes have been well taken care of so that they do not pose any environmental hazard. And most of the process wastes, they are either recycled or reused, like you see fly ash, we have mill scale, baghouse dust, slag, wood waste, e-waste, used battery, acid waste. Almost all of these are recycled within the processes. The fly ash, we have an ecosystem for utilization of fly ash in our industry. We are operating thermal power plant, and the fly ash is fully utilized. There is 100% utilization of fly ash in bottom ash. Fly ash is totally used in cement as well as brick manufacturing. So in that zone, the clay brick manufacturing is banned, and only the fly ash bricks are manufactured in our nearby areas, our plant. Regarding our sustainability, we have several reporting and disclosure programs. We have the BRSR, we have the sustainability report, we have product carbon footprint coming up under ISO, aligned to ISO 14067. This is the product carbon footprinting standards. And we are getting our product carbon footprint assessed, validated and certified by third party. Carbon border adjustment mechanism. This is the new aspect which we are seeing, where the European Union has unilaterally imposed the CBAM taxing mechanism for all its import. This is what they say is aligned to the EU ETS, European Union Emission Trading System. But however, this is skewed towards the European Union, because as such we see the Indian context of steel manufacturing. We have a grid which is not as green as the European grid. The European grid is almost, you see there is, we just saw in a previous presentation, Mr. Sherry was presenting, the grid electricity is at 0.5 or even below. The grid emission intensity in North Europe is at about 0.2, while in India the grid emission intensity is almost 0.9 to 1. So that brings our scope 2 at the very high levels. So to attain our emission intensity comparable with the European Union, we need the Indian electricity grid more green. How to achieve that? So Indian green energy missions. There are several programs we have seen to add green electricity into our grid. There have been several PPAs have been signed. So it will take time for our Indian grid to become green, which can support the green manufacturing of stainless steel and steel. ESG ratings, we have the third-party ratings and independent ratings by Sustainalytics, EcoVadis and Gsse. Transitioning towards sustainability. The stainless steel, as we all know, this is operationally this is the most sustainable material. I won't say much into this. All are here as stainless steel experts. Material efficiency, recyclability, durability, corrosion resistance. The lowest possible carbon manufacturing route, that is stainless steel, it's possible to manufacture through EF route. As both of our general stainless plants, we have electric arc furnace route. Design flexibility and safe for food and healthcare. Different routes of steel production. This is a table which I have given. It's a basic comparison between different processes of steel production. Conventional, BF-BOF, the best available technology with BF-BOF. We have best available technology, BF-BOF plus carbon capture, then scrap-based EF, the DRI-EF, and the DRI-EF plus natural gas. As we can see that the scrap-based EF, this process is going to have the lowest carbon emission intensity compared to any other process. So Jindal Stainless has this process, the scrap-based electric arc furnace route. So inherently our processes are having much lower intensity, carbon intensity than any other process of steel making. And stainless steel itself, given the life cycle assessment, the stainless steel itself has a much lower life cycle emission intensity compared to any other steel. This is the steel production routes, just in continuation to the previous slide. More than 80% of the root steel is produced by the primary routes, mainly using sponge iron, mainly using iron ore and with some scrap. And 7 to 9% of the steel making is 7 to 9% emission are by the steel globally. So these are the emission intensity. The bottom slide where was shown. So scrap-based EF has the lowest carbon intensity and the lowest energy intensity. What are the pathways for green steel? In the Indian context, the National Mission on Green Steel is trying to define the green steel would be that steel that is produced in plant whose emissions are at least 10% lower than the weighted average permissible carbon emission intensity during the period of production. The permissible emission intensity will be determined by the National Steering Committee of the Indian Carbon Market. This is what I am trying to say here is, as of now, there is no green steel standards available worldwide. Every company has defined its own standards and have marketed using certain parameters, comparable parameters. Indian government Ministry of Steel is trying to come up in consultation with all stakeholders to define green steel. So as of now, there is a paper which has come out. The green steel will be the one which will have at least 10% lower weighted average permissible CO2 emission in that production period. So we'll see how this firms up in the coming period. We are going to shortly have the declaration on the green steel standards in India, and we are quite confident that we'll be able to align to those, given our processes and the flexibility in our processes. So this chart here, we are presenting that the decarbonization pathway, how it looks like in the Indian scenario. That present in 2022, we have about 150 to 160 metric tons of crude steel production, million tons of crude steel production, while the projected in 2050 is about 576. So there will be a shift towards the net zero economy through the hydrogen-based economy will form the bigger chunk to attain the net zero by 2050, and it will be supported by the scrap-based and the carbon capture. These are the few levers to make green steel, green hydrogen, renewable energy, carbon capture utilization, scrap utilization, and energy efficiency. There are some initiatives being taken up by different steel plants for attaining the green steel standards: scrap-based EF, blast furnace, BF, substitution of coal injection, blast furnace by biomass, green hydrogen, non-coking coal-based DRIEF, natural gas-based DRIEF, 4x with O2 converter. This is the certain existing steel plants are trying to attain green pathway through these methods. This is the forecast. We are getting that by 2030, India is trying to achieve a capacity of 300 million metric tons of steel production. This is the general steel production, not only just stainless steel. So total steel production by 2030 will be 300. So as of now, you can see in 2022, the demand is about 120 million metric tons. And we have a carbon emission in India of 2.3 billion tons of CO2 has been emitted in 21-22. So if the steel production rises by 3 times, and this goes unabated, so we will have 3 times of 2.3, that is about 3.9 billion tons of CO2 that will be emitted if the processes go unabated. So there is a very big concern. So we all have to see how our steel productions are sustainably they are manufactured and we are able to reduce our carbon footprints. Apart from our direct emissions and indirect emissions, the scope 3, apart from our purchased material and goods, the logistics, that is a very big contributor towards the scope 3 emission. As of now, in the logistics, the mode is skewed towards the road. As you can see, 71% is logistics is utilized by road, and while rail is only 1.7%, 17%, and waterway is 5.8%. So this skew is causing the carbon emission that is associated with road is about 101. In the railway, it is 26.5, and waterway is 11. So the more if we can shift through dedicated freight corridors and several concerted programs, we can switch from road to rail, we will be able to reduce the carbon emissions that are associated with the logistics. There are certain cost disadvantages in the Indian steel industry, logistics and infrastructure related, cost of power, import duty, clean energy cess, taxes and other duty of iron ore, cost of finance and total, and sustainability are coming for the same cost. I have listed out some challenges of industry readiness. Large-scale hydrogen usage, lack of know-how in hydrogen metallurgy, high energy consumption, hydrogen specialist handling and safety, suitability of slag as a co-product, and the bottleneck of scale-up of hydrogen, low-grade iron ore, lack of reference in engineering design, lack of hydrogen-approved equipment and components. So basically, what I am trying to say that going forward, we have the challenges associated with the green steel pathways. The known pathways for the green steel being renewable energy, the hydrogen usage, and renewable energy, as we all know, that is variability in nature, the grid, the carbon intensity of the grid, emission intensity of the grid, variability of the renewable power, and the lack of availability of hydrogen at large scale is slowing down the adoption of green hydrogen, and also there is a long way to go to achieve our green steel standards. But however, we at Jindal Stainless, we are looking forward to developing our own green steel batch, depending upon the customer choice and customer demands. We are ready to manufacture green steel batches using the right mix of products, right mix of energy, and we can certainly produce green steel, and that will be scaled up economically. So this is it. Thank you. Thanks a lot.
But I represent an industry where I can probably solve the problems which these people have said about the carbon dioxide. We have been hearing about the challenges that we have in carbon dioxide, and therefore my company, which is called Aker Carbon Capture, it's a Norwegian company, we have certain solutions to really offer to the steel industry as well. So I'll be speaking less of the steel industry, but generally about the ways and means of, decarbonizing the industry as a whole, and partly how we can help the steel industry as well. So the most important thing for all of us to remind is there is a huge biodiversity loss because of the extraction of natural resources. And the numbers are very huge. There is also a stress on water. And therefore, any industry which is using natural resources, which includes obviously the metal industry, which also includes the industry wherein I spent my life, that is oil and gas industry. So it's a very challenging situation. How do we protect the earth or the world where we are staying in? And this is leading to several issues: pollution, climate change. Today, people like us who travel, it rained very heavily. So it rains at any point in the time. You cannot really decide when to hold the cricket matches, because in one day can be simply lost out. There is a habitat loss, and there is a huge stress on the water. So we are in a very challenging situation, and we have a responsibility. Now, metal industry is a very significant contributor to the emission of carbon dioxide. So if you see this graph, you will find that, of course, the transportation industry is one of them, the power industry is one of them, but metal industry is also a huge contributor to carbon dioxide emission. So the numbers are very huge, and I really compliment the speakers from Autocompo and Jindal Stainless for the initiatives that they have taken. And it's not going to be that easy. So for decarbonizing any industry, there are two ways in our opinion. There are some pathways. One is there is a demand side and there is a supply side. So how do we fix the demand side? You know, you use steel for any industry, you need equipment. Are we optimizing the designs to ensure that we need less steel for our product, our equipment? We still don't have enough, I would say, optimization in our design. That's one part. There is also an opportunity on material substitution, and any material which can have less carbon footprint, we should look at it from that point of view. So that is the demand side of the material utilization, where there is huge scope. And then there is supply side. So you have heard about carbon capture, green hydrogen, and these are some areas where our company can probably contribute to improve the carbon footprint. So our company has developed some unique strengths, and these are in the areas of capturing carbon dioxide. So people think that once you do the carbon capture, your problem is solved. It is not true, because the captured carbon dioxide has to be also released again. So we have to have a means of utilizing that carbon dioxide, and that is something extremely important. Secondly, the technology for carbon capture is a very conventional technology. So what kind of solvents we use for each of the processes? So there is a way to select a solvent, and it's not just one solvent which fixes all the problems of the industry. So we have to analyze the composition, and that is something which is extremely important. And then we have to also have, validated and certified, system by which we can say that our emissions are really controlled. And one of the, I think you said that about the transparency which is required for measuring the carbon dioxide, and it is extremely important. So all these three things related to carbon capture focus, and also selecting the best in class solvent which will have a good, I would say, it's a green solvent, so that it doesn't create another carbon footprint issues. That is something which we have to look at. So in Norway, they started this initiative in the oil and gas industry, and that happened in 1996, where the carbon dioxide which is emitted offshore, they ensured that they capture that carbon dioxide, and then they put it back into the reservoir, and that started quite some time back. Then subsequently, of course, there were mobile test units for flue gas testing. There are some solvents which were produced in collaboration with some technical institutes, and it kept on developing the industry in a way, so that we collaborate to reduce the carbon footprint as a whole in a very holistic manner. So a lot of such applications you will find in the industry which are of great value. But for metal industry, so there are some industries which I have. So cement industry, our company is already executing a project with 400 tons per annum carbon capture. Then in Netherlands we have the waste is burnt, the carbon dioxide is captured, and it is released into greenhouses so that the carbon dioxide is utilized. In case of the cement plant, it is stored in a underground storage. And Ørsted is a biomass power industry, where again we have carbon dioxide capture, which is a current project which is ongoing in Denmark. But the picture on the right may be of interest. I have some more details on that. That is for the metal industry, and it is for Elkem. And it is of course not an iron industry, but it is a ferrosilicon, which is an alloy, where they are trying to have a mobile testing unit to try various solvents, because there is a huge potential to do carbon capture. And there are two projects in the UK where we are capturing, we have done some conceptual and field work for 2 million tons of carbon capture. Kit B is also the second one. And this is the collaboration and partnership with various companies for developing the technology along with the gas turbine. We are working with Siemens. We are optimizing our heat cycle with MAN Energy. We are working with Microsoft for digitalization as well as selling the carbon credits. Quench is the waste to energy kind of thing, so municipal waste can be burned and carbon can be captured. So the application of carbon capture is all around, including the metal industry. But what I want to tell you is it is not as straightforward as it looks, and that is the reason that the largest producer of stainless steel in India, like Jindal Stainless, there are so many plants and there are so many, experimentation which is going on, because it is not that straightforward. Same applies to a company like Outokumpu, which is one of the largest producer of stainless steel, because the whole solution costs huge amount of money. It is not that economically viable still. So you have to continuously keep optimizing. So what our company has done is we have a mobile test unit. So we run campaigns with almost like the entire plant, with absorption, the contactor, the desorption, the heat cycle, the storage and everything that is required. And then each of the plant where we have an application, we try different solvents so that you know whether what is the energy required to regenerate the solvent and whether it makes sense to put that particular solvent. So we have to have a lot of patience to really implement that technology. And whatever are the components of the main plant, they are in this mobile test unit. And it can be transported on ground. Most of the units are designed in a modular way so that you can assemble them at site. And you can take them to steel plant, you can take them to power plant, you can take them to cement plant or wherever required. So that is how we believe that the industry will go forward. So this is the one which is currently for the industry, which is the metals industry in Norway. So there are, now if you see the number of companies involved, it involves so many companies, like approximately 12 companies including our company. And the collaboration is done in a very transparent manner. You share the data with each other. You try to make a cluster of various industries which are discharging carbon dioxide. So there is a potential to track 2 million tons of carbon dioxide in this location. And then the mobile test unit will test various compositions, decide on the best solvent and go to the next step of the actual plant. So this is where we are. And then each of the carbon capture plant, if it again generates the carbon dioxide for regeneration, it's not a very fair thing. So we measure the carbon footprint of each of our plants. So if you see here, the metals which are used in the carbon capture plant have quite a significant contribution from the steel industry. So if you look at the production of steel materials, it has 43% contribution on the carbon footprint of a carbon capture plant. So you have to have a very systematic way, a structured way to see what is the carbon footprint of your plant. Because on one end you are saying I am going to capture the carbon dioxide from your plant, but I generate a lot of carbon dioxide, so it makes no sense. But the pie chart which you see, which I thought is very important for you to look at, the impact of the cost if you make steel with low carbon footprint, the capex has a very small impact compared to the opex which you will have. So therefore it makes sense for the steel manufacturers to implement processes. It may cost something more now, but eventually the cost will go down. But that will help the whole industry to really decarbonize in a real sense, in a holistic way. So many companies, like approximately 12 companies including our company, and the collaboration is done in a very transparent manner. You share the data with each other. You try to make a cluster of various industries which are, discharging carbon dioxide. So there is a potential to trap 2 million tons of carbon dioxide in this location. And then the mobile test unit will test various compositions, decide on the best solvent, and go to the next step of the actual plant. So this is where we are. And then each of the carbon capture plant, if it again generates carbon dioxide for regeneration, it's not a very fair thing. So we measure the carbon footprint of each of our plants. So if you see here, if you have any questions, feel free to ask.
I'm Jayaprakash from Steel Mint. I have two questions actually. How the industry will absorb the cost? Since India and Europe, these are based on the scrap-based production. So definitely they don't have the cost competitiveness which China has currently, who is making stainless steel based out of NPI. NPI has more emissions since it is produced from the primary route of production. But still, India needs a lot of stainless steel and also the affordable stainless steel. That's why I think one of the big producers is expanding its production from the blast furnace route. So that is again going to increase the emission. So these are the two questions. What should be our priority as an Indian industry?
So as I have explained that, first of all, the definition of green steel is still not clear. So I think when somebody is asking what is the price difference between a normal steel and a green steel, I think then we need to understand it better. So for example, if I am saying that Circle Green, which Outokumpu has launched, and the carbon dioxide footprint is 50% of our normal stainless steel, isn't it? So that we are calling it Circle Green, but we are not saying it is zero carbon. We are still saying it is emitting carbon dioxide. And when you are making certain change in your process, it will have a cost impact. So for example, as I was explaining, in scope 3, which is related to raw material, and in case we have to procure raw material which are more carbon neutral or have less carbon, the cost of those raw materials are also higher. And also when we were discussing about energy cost or production efficiency cost, so everything has an impact on the process and production cost. So definitely there will be a premium, and customers who believe in sustainability, customers who believe in environment, they are willing to pay premium for such material. I cannot tell you the exact number, how many euro per ton or how many rupees per ton, because it depends on different kind of grades that we are producing. So there is definitely a premium. And that premium we are discussing with the customer on case-to-case basis.
See, there is always a cost attached to something which we are trying to make it sustainable, because the ecosystem in which we are working and manufacturing, that is itself not green. So if you talk about the blast furnace producers, who though, yes, it is the lowest cost production route, but that is not the green. So the worldwide, there are two ways that it can be made green. Worldwide, there is a shift towards the DRI production route. But for DRI, you see that to achieve a high rate of metallization, the requirement of hydrogen as a reducing agent has to be switched. So there is a switch from natural gas to hydrogen, and also to attain a high rate of metallization, the ore has to be of a very good quality, the iron ore. In blast furnace, that is not the constraint. So when we are shifting to DRI, there will be much more constraint with the availability of ore in lumps and pellets, and as well as the reducing agent, that is hydrogen. So it's only switching to DRI, but hydrogen availability. The hydrogen availability is a constraint. To make 1 million ton of steel, you require about 55,000 tons of hydrogen. And the hydrogen cost today is about $4 to $12 per kg. And unless that comes down by the way of renewable energy being available at cheaper rates, as well as the electrolyzer technologies, the hydrogen is out of reach from the normal manufacturing processes. So this is as concerned to the hydrogen, where it can be utilized by the DRI manufacturer. Stainless steel as of now, like Outokumpu and Jindal Stainless, we are making it through electric arc furnace route. To have more of a green production, we require access to renewable electric energy, that is green electric energy. Green energy, as of now in India, it is a constraint because grid is not green. And to add at your own cost means what JSL is trying, it is trying to add its own renewable energy by setting up its own renewable energy plant. But that is costly affair. It is not as good as the grid electricity which is available round the clock. But to support that renewable energy which is having a variation around the year and around the clock, we need the backup energy. So there are the electricity regulations, the power regulation in India are not very conducive towards banking, towards utilization of renewable energy, because there are so many things. If you are tracking the electricity regulation developments, there are banking charges, there are standby charges which have been announced. So many things are adding on to the cost. So that is not coming for free. With the transition towards green, it is not coming for free. To some extent, let's say, if you want to reduce it by some percentage, let's say 10, 20, it may come at a very negligible cost. But when you want deep decarbonization, then we have to deploy several other initiatives like carbon capture, which is a very complex technology. As of now, it is technically not viable. I mean, commercially, it is not yet viable. So when you switch to deep decarbonization technologies, you need more funds, more capex, and that will certainly drive up the cost. So finally, it is the economy where if the customer is asking for the green steel, green product, might be there is a compulsion for them to produce the final product as green. So it has to be a chain economy. It's not just that we produce it and try to market it. Unless there is a demand supply pull push, it cannot happen. So that entire chain, manufacturing and consumption value chain has to evolve towards a green and sustainable product. And that is the cost is attached to it. What will be the cost? How much the marginal cost will be? That will be decided by the different energy transition and other things which are happening year on year. And by 2030, we will see a lot of evolution through government policies, through several industry collaborations. So we will see how it evolves. Thank you.
Can I add something? So, everybody is looking at the cost in a very isolated way. But the way we are looking at carbon footprint with scope 1, scope 2, scope 3, we have to also look at the cost as scope 1, scope 2, scope 3. And in that, the cost of floods, for example, what is the cost of floods which are happening, or what is the cost of this climate change? Would it not get added as a cost otherwise? Then people will automatically pay more for the green steel. And that will be a small percentage of the cost compared to the cost of this environmental challenge that we are facing. So slowly people are realizing that if I invest on this today, it is really going to benefit me. So one has to really look at it from that point of view as a big picture rather than looking at just today's business. That is the only point I want to make.
So you have shown in your slide that blast furnace route you had mentioned different routes of steel making along with the emission levels. So I was looking at the scrap route. It has 1/3 less emission than the other routes. Right now, it is very challenging, to secure scrap from export markets like EU and US. So since Autocompo is in Europe and there are a lot of talks that they are going to ban scrap export to the Asian countries. So since we don't have a reliable technology right now to reduce the carbon footprints, as you were mentioning that carbon capture technology that is not evolved, it is not commercially or technically viable. So we cannot implement it right now. What we can do is we can reduce our scope 3 emissions by changing our charge mix, by adopting scrap more in steel making, especially for stainless steel. So what is your view, means a joint view, that will it be a good move to implement CBAM and scrap export ban? That will be very unfair for the Asian countries. So, yeah.
Let me just correct one thing and then, of course, Rajiv can answer your question. See, when I say that carbon capture technology is in terms of cost, we have to further optimize. I'm not saying it's unviable, okay? Otherwise, I'll be out of business. You understand me? So we have to continuously improve the cost of such products because the technology is continuously evolving. I was only telling that you can't just use one process, one solvent, because it is just absorption and desorption, and that's the end of the technology. We have to optimize the technology, optimize the process depending on your flue gas composition so that you get the best cost or the optimum cost. Now, it's all relative. What is the cost of technology, etc. So we have to keep in mind that everything that we do, we have to continuously improve so that the technology cost keeps going down and becomes affordable at a large scale. Because there are two things happening. One is we are implementing a new technology, and today the capacities are less. And then we will continuously increase the capacity. What happened in case of, say, mobile phones? What happens in case of solar industry? What was its cost when we started and what is the cost today? The same thing will happen to every technology, because there will be advancement in the technology and there will be an effect of scale. Okay? So the next point, of course, related to scrap and the challenges that we are facing. Rajiv, you can take it.
So availability of scrap, definitely it is going to become more and more challenging in future when more stainless steel producer increase the percentage of scrap. So that is, of course, will be there. And in India especially, the availability of scrap is low because we are not like usage of stainless steel is growing now rapidly. But as compared to Europe, USA, they generate more scrap as compared to us. So as I was mentioning, I think scrap should not be our only focus to do decarbonization or for more sustainability. There are many other ways to look into, and I was mentioning about the scope 3 emission, and there we need to see that nickel and chromium and lime, which were the other three main raw material, from where the biggest pie, you have seen the graph, that 2.7 million ton was coming only from scope 3. So there are opportunities. I think we have to become more and more innovative, and we have to see where are the more opportunities, where it is a cost-benefit analysis also. Because as the demand of scrap will increase, the price of scrap will also increase. So we have to be very innovative in that way.
So we are here not advocating for the scrap-based production route alone. It is not feasible. So we have to see equally all the process routes should be economically and environmentally viable. Scrap will be in demand. If we say blindly we follow the scrap route, yes, that is a low-hanging fruit as of now. It's easily achievable. That already has a low carbon footprint, but doesn't mean that we have to abandon the other production routes. There are technologies going to be involved, like the blast furnace route. We have the solution in the carbon capture and utilization that is coming up. Once it gets matured, the usage of hydrogen and carbon capture combination will be fruitful for the blast furnace route manufacturing. So it's not that we have to solely depend on the scrap-based production route. We can also feasibly work out other deep decarbonization methods. And certainly the scope 3 is one area where we need to focus. The dependency on the logistics is the major area for any steel industry, is the raw material and the finished goods. The logistics is very important. So presently the rail network in India, it is not that dedicated towards this. So there is a heavy dependency on road, and which the pollution level is very high. So this entire economy has to be evolving in terms of availability of dedicated freight corridors, rail network up to the last mile solutions, waterways, decarbonization and shipping industries, and several other things which will bring in an overall move towards green steel. So the greenness is not just limited to scrap. We have to equally give due importance to all forms of steel and all processes. So that's it. Thank you.